Welcome everyone to the Washington Statistical Society's Memorial Seminar for Carol Blumberg. My name is Catherine Iramata, and I'm the current WSS Methodology Program Chair, and I'm chairing today's seminar. Today, we're going to be hearing from two of our colleagues, Mike Cohen and Chris Franklin, who are here to honor Carol Blumberg today. So I'll start by introducing Mike, who's going to highlight some of Carol's many outstanding contributions to the statistical community during her career. Mike Cohen is a principal statistician at the American Institutes for Research. He had a long career with the federal government, including 13 years at the National Center for Education Statistics. Mike has a variety of research interests, but most are statistical issues related to sample surveys. He's a fellow of the American Educational Research Association and of the ASA, and he's a former president of the WSS and of the Washington Academy of Sciences. I'll turn it over to you now, Mike.
Yes, well, let me first of all thank Catherine, Sabrina, and Mark for organizing this. And Chris is our main speaker today. I'm just going to make brief remarks. Carol Joyce Blumberg was one of my best friends. And I have to say up front that she could be very critical. So she was not everybody's cup of tea. But she was always very constructive, and she was always a force for positive change, and she got things done. She was a mover and a thinker and a shaker. I met Carol before she moved to the DC area. We had a mutual friend, Pam Bruni, who's on this call, and I met her in the late 1980s. She's from the Detroit area and got her early education at the University of Michigan. Well, or college education, the bachelor's and master's degree, and then she got another master's and a PhD from Michigan State. Her PhD was in education psychology, but she had a heavy dose of statistics in her program, and I'm told that she was a top student there. She had a brief, after her PhD, she had a brief stay at the University of Delaware, but then she found a home at Winona State in Minnesota, where she had a long career, and she mentored many students, some of whom are in the Washington, D.C. area now. We also have students, we also have people in the Washington, D.C. area who knew her from Michigan State. She moved to D.C. in 2006, and she wanted a second career with the federal government, and she found a job with the Energy Information Administration. When I became president of the Washington Statistical Society in 2007, she came to me and she put it, she wanted to help wherever she was needed most. And you can imagine how refreshing that is to hear when you're a leader of some organization. I asked her to head up the data collection methods program because that was relatively inactive at the time. And she went on to lead that for several years and had a very active program with many great speakers and did a really good job. But then after a few years, she announced, and this is her term, she's going to retire from that position and become do what she wanted to do and go back to education statistics. She actually carved out her own program within the Washington Statistical Society to do that. I'm not that well versed in her career at EIA. Maybe will be some comments from the audience later about that. But I do know that she was at EIA a relatively short period of time when she organized an invited session at the International Statistical Institute biannual meetings. And it was the first such program that they'd had in many, many years. So I was really amazed that within such a short period of time at EIA, she was organizing this international meeting. She had a great network of friends, both nationally and internationally. We were just talking about her contacts in New Zealand before the session started. Okay, I think I will, at this point, turn the podium, virtual podium back to our chair. Gotcha.
Thank you so much, Mike. Yeah, we really appreciate that thoughtful tribute to her and just for recognizing her and her work. So, as you mentioned, the second part of our seminar today is going to be a presentation from Chris Franklin, which is titled Data Reasoning at the School Level, A Journey of Impactful Disruptions. And this is really in honor of Carol's work in statistical education. So let me go ahead and introduce Chris before I turn it over. Chris is the American Statistical Association's K-12 Statistics Ambassador, an ASA Fellow and UGA Emeritus Statistics Faculty, and recipient of the ASA Founders Award and USCOT's Lifetime Achievement Award. She's the co-author of 2 introductory statistics textbooks, chair for the ASA Policy Documents Pre-K-12 GAZE, Statistical Education of Teachers, currently co-chairing the Set 2 revision, co-chair for the updated Pre-K-12 GAZE 2, and a writer for the NCTM High School Catalyzing Change. She's the former AP Stats chief reader and a past Fulbright scholar to New Zealand. Chris welcomes opportunities to collaborate and share her love of statistics and data science with teachers, educators, and students, plus advocating for statistics and data science in her role as the ASA K-12 ambassador. She's crazy about running, hiking, scoring baseball games, reading mysteries, and a mama to her grandchildren. Earlier, you have so many different interests and experiences. We're really excited to have you and give this presentation. So just a quick note to our audience before we get started. If you have any questions during the presentation, you're welcome to submit them in the chat, or afterwards you can raise your hand and we'll take questions that way. So I'll now turn it over to you, Chris.
Oh, well, thank you so much for that nice introduction. First of all, I want to say how honored I am that you asked me to join you today and honor Carol. I met Carol over 25 years ago. And as Michael said, she was a force of nature when I met her, but it was such a good way. And she has been a great colleague and friend for the past 27 years, I think. And I'm really going to miss Carol. I'm going to miss her kindness. I'm going to miss her forthrighteousness, her generosity. She was an inspiration for me, and she supported me so much through the years in my work in statistics education. So I'm just really honored to be here today to talk a little bit about the work that we've done at the school level that Carol very much participated in. So let me share my screen, and hopefully I can manage the technology okay. And let me start my slideshow. Hopefully, can you see this okay?
Yep, we can see it.
Well, when I started thinking about what I wanted to talk about, I started reflecting and I realized that in all the years that I knew Carol, I thought about the different work that we did together, the work that she participated in, and I thought it might be nice to talk about the journey that I think both Carol and I participated in as we tried to support statistics education, especially at the school level. I have to say that my years in statistics have been very stimulating and what I call joyful. I couldn't imagine another career than what I've had. And I found this photo. This is a photo of me with my youngest son. This was taken in 1996. And it was actually around that time that I met Carol. This is taken in my office. I thought you might enjoy looking at the computer that was on my desk. And this is all before Google. And I thought about how I started out as a teacher in the 80s and where I am today, and how we think about teaching statistics to our students, how we think about doing research for our students, and the content that we're actually teaching our students today compared to maybe what we were teaching in the 80s or the 90s or the 2000s. As I looked at that picture also, and that's my youngest son who was 1 year old at the time, I think as parents, we all think about what we hope that our children will grow up to be. We want them to be good citizens, but we think about what their careers will be as well. Well, I never imagined that this 1 year old would end up in cybersecurity, that his job would be to protect our data. And then my oldest son, I never imagined would become a data geek forester. Now I could imagine him becoming a forester, but I never imagined that his entire career is all about collecting data. Now he does collect data the old-fashioned way with a tape measure, measuring trees, but he also works with fancy GIS systems. He works with drones. This was all foreign to me at that time. And it really made me stop and think about how we have evolved in the way we think about data and the way we analyze data and how data affects us both personally and professionally. And as I further thought about it, I decided maybe I could categorize it as disruptive events that have occurred since the 80s and the career that I've had and also the career that Carol had. So what does it mean to be disruptive? It means to prevent something from continuing or operating in a normal way. For example, disruptive technologies such as the first iPhone in 2007. And in turn, how have these disruptive events, what have been the consequences in terms of statistics education? As I think back to being a student, and also in terms of my teaching, I think one of the people that influenced me the most was John Tukey. And I love this quote by John Tukey. The best thing about being a statistician is that you get to play in everyone's backyard. And I think that is more relevant today than ever. And the reality is that data surrounds us. We can't get away from data. And we need to start thinking about how we educate our students beginning at a very young age in elementary school. John Tukey, in my mind, was a disruptive force. He changed the way we thought about approaching data. Instead of approaching things from a more inferential perspective, performing inference tests using mathematics, he encouraged us instead to approach data from an exploration standpoint. And that changed the way that we thought about teaching our students. Another individual that I consider a disruptive force was Fred Mosteller. When he was president of ASA in 1968, he reached out to the president of NCTM to form what's now the joint ASA-NCTM committee. In other words, he saw the importance of trying to move our statistics education from the post-secondary level to the school level. This committee, I've been told, is probably one of the hardest working and most productive committees of ASA. What were some other disruptive forces? Well, as a student in the 1970s, and then once I began my career in 1980, the technology, of course, that came along. Now, of course, when I was a student, I was using punch cards and I was programming. But this did change the way we began to think about teaching statistics. And in the 1980s, one of the important results or products that came out of this joint ASA and CTM committee was the Quantitative Literacy Project, what we oftentimes call the QL project. And notice, one of the books that came out was The Art and Techniques of Simulation. And this is when we really began thinking that we could move the teaching of statistics to the school level and not rely on mathematics as our background, our foundation, that instead we could turn to simulation. So what were some other disruptive events? Well, in the 1990s, the scientific calculator, the TI, the HP that came out. And what this helped to do was move teaching statistics from emphasis on procedural and computational to more conceptual understanding and data sense making. And of course, around 1996, the internet was becoming more useful to us. And then in 1998, another disruptive event, Google arrived. Well, in the 90s, after the TI calculator came out, it was in 1997 that the first AP statistics reading was held. And here is a photo of many of the initial readers and leaders that were at this first reading. And I want you to notice on the first row, we see Carol. And this is where I actually met Carol, was at the first AP statistics reading. She and I were in the same reading room, and she was amazing. And I just cherish the friendship that I have with her from that time. But of course, an integral part of AP statistics was the technology that we were now able to incorporate using the calculator to where the course could be taught from a more conceptual standpoint. Of course, in the 2000s, here came the laptops, and then we began to see statistical software. This once again had helped us to evolve in how we thought about teaching statistics at the school level, as well as the undergraduate level at our universities. And then some seminal documents with recommended learning outcomes began to appear. In 2000, the Principles for Standards in School Mathematics from NCTM was a major document that included not only algebra, geometry, the basic strands we think of with mathematics, but it also included a data analysis strand. Then in 2005, the GAZE pre-K through 12 GAZE report appeared. And this became a document that was beginning to be used by states throughout the US as well as internationally in developing statistics standards. In 2015, the Statistical Education of Teachers appeared. ASA began to also at this time begin to put lots of efforts into resources for our teachers. And Carol was a major volunteer in helping to gather these resources, develop these resources, organize these resources to where teachers could easily access the resources. So what have been some other disruptive changes? Well, of course, personal devices. And what did this do but just lead to the explosion of data? One of the things that I think it's really crucial that we help our students understand is how much data individuals generate every day. And a person on average generates about 1.145 trillion megabytes of data per day. And we don't think about that, but with all the applications that we use on our computer, our phones, our iPads, it's amazing. And so how has this changed our teaching? Well, it's changed the types of data that we work with and the size of the data sets we work with. And it's changed whether we're working with secondary data, available data versus primary data, data that we design ourselves as researchers. We also gather data on ourselves, part of the quantified self movement. So with all of this, what do we do with this data? And how do we try to tell a story with this data? Well, one of the things that has happened because of all these disruptions, especially with technology, is that data visualizations are now just amazing. What we can do with data visualizations. And as John Tukey said, data visualizations help tell a story. Two quotes that I'd like to look at that came from John Tukey. The greatest value of a picture is when it forces us to notice what we never expected to see. Another quote from John Tukey. Visualization is often used for twisting data changes and making them look meaningful. Present present results clearly and honestly. One of the things we're doing at the school level in teaching statistics and data science is we're trying to help students understand the power of data visualizations, but we're also trying to help them understand how important it is to question what you see in data visualizations and try to understand if an accurate story is being told. Just to give you a couple of examples of what I think these quotes mean. Here's an example from the first quote. The greatest value of a picture is when it forces us to notice what we never expected to see. Hopefully, many of you recognize this as the popular Florence Nightingale polar diagram. And this is where in the Crimean War, she collected data and she demonstrated that it wasn't war wounds that were killing most of the soldiers that were passing away, that instead it was the sanitation of the hospitals that they were using. And because of her work in the Crimean War, major changes were made in England in how hospitals operated in terms of sanitation. Now, what's an example of a visualization is often used for twisting and making things look meaningful? Present results clearly and honestly. Well, this is a graph from COVID. And I think during our years of COVID, many of us began to realize more than ever the importance of our students graduating from high school where they have a foundation in understanding how to make sense of data. This was a graph that appeared in Georgia, my home state. And the graph was trying to show basically the trends of COVID over a period of 15 days. Now, hopefully you can see the graph well enough. I'd like for you to look at it. One of the things that bothered me when I first saw the graph was the blue background, the dark blue background, because it made it very difficult to see the labels on the graph. But if you can see the labels, I'd like for you to put in the chat what you might notice about this graph that bothers you. I see one response in the chat. When you say the dates are not in order, as by descending frequency, So yes, like a Pareto chart. So yes, it seems that you've noticed, and the counties are not consistently ordered. Yes. So the dates are not in order, and the counties are not are ordered within the dates. So how could we tell why do you think it was set up this way? What do you think, what story is being told from this graph? In terms of COVID. COVID is going away. I like that. Well, what would happen if we, instead of presenting this graph, presented this graph? The one on the left compared to the one on the right. Now, the one on the right was the original graph. What's different about the graph on the left? Do you like the graph on the left better than the one on the right? I see yes. Proper ordering by date and counties. Very good. Is the same story being told from the original graph? Is COVID going away? Not as clearly. Yes. Well, fortunately, people recognize that the original graph was incorrectly drawn. And within an hour of its publication, there were several comments sent to the governor's office and to the Department of Public Health. And the next day, they sent out a corrected graph. But this is the kind of education that we want our students to receive in terms of how to make sense of statistical information that they receive and knowing how to ask the right questions about that statistical information. Now, in terms of visualization, one of the things that we're working with a lot with our students now at the school level are photos. Why photos? Well, with our cell phones, those are now our cameras, and students are taking photos all the time. So how could we possibly use photos in our work in statistics education? So let me now play this video for you. I want to introduce you to Dollar Street.
Anna Roseline is dedicated to using art and science to help us make sense out of a complicated world. One of the best examples is her work on Dollar Street.
It's a live website that is free for anyone to use. We are using photos as data to actually make the world understandable by showing everyday items from homes from all over the world. Each home has a set of the same imagery as the other homes. So it's about 150 things in each home we try to capture in the same way. The houses are organized along a street where you have the poorest to the left and the richest to the right. People hate data, even if you make them colorful and moving. But if you use photos, there is a slight passage you can reach their brain. One of the reasons I started Dollar Street was because I was so fed up by people talking about people being poor, that was their culture, that was the way they wanted to live, and we should not interfere.
Thanks to her efforts, we're able to see ourselves and others more clearly.
In the long run, I'm hoping that Dollar Street will be included in all school education all over the world, so school kids get to understand the world around them.
It's so eye-opening, and it's valuable to see what's going on at these different income levels, what life is like.
With Dollar Street, I think you can actually change the way people see the world, and I think that is the most powerful thing.
Dollar Street is wonderful, and we encourage teachers to think about using Dollar Street in their classrooms. In fact, there's been lots of activities that have been developed by teachers using the photos from Dollar Street. And many of those some of those activities you can actually find in our publications at ASA. So not only do you have photos that you can draw from the web or from sources like Dollar Street, but just from your telephone and the iPhotos or the photos that you have with any of your phones, the information that you can learn from a photo. And we try to encourage our students to think about that information, but also to think about when they're sharing those photos with others, what information they're giving out. Now, fortunately, phones now have it to where you can control how much information goes with your photos when you load them up on Instagram or Snapchat or Facebook or whatever social media you might use. But this brings in the whole new topic of ethics and how we utilize our photos and the information and data that we share from those photos. So the heart of all of this is the statistical problem-solving process. And one of the things that we've tried to do with our documents at ASA, the pre-K through 12 GAZE document originally published in 2007, and now the most recent one published in 2020, is to help teachers understand that the foundation and the heart of statistics is the statistical problem-solving process. Becoming healthy skeptics of statistical information and always asking questions about not only the investigative question, but the design of your study, the analysis, is it appropriate, is the conclusion reasonable, constantly interrogating the data itself. And I thought what I would do is I would share with you another video that I actually made for the Georgia Department of Education. The ASA has worked with several states as they have implemented more statistics standards into their math curriculum. And some of the states have actually asked ASA to help them with filming videos and developing resources for their teachers to use in their classrooms. And so I'm going to share with you a video that I made for the Georgia Department of Education that talks about the statistical problem-solving process.
Hi, I'm Christine Franklin, current K-12 Statistical Ambassador for the American Statistical Association and Emeritus Statistics faculty at the University of Georgia. I'm excited to introduce you to the Pre-K through 12-2 document endorsed by the American Statistical Association and the National Council of Teachers of Mathematics. GACE 2 makes recommendations for the learning objectives and skills K through 12 students need for making sense of data that surrounds them in today's world. GACE 2 is downloadable free from the ASA website. Core to the GACE 2 document is the statistical problem-solving process. Formulate statistical investigative questions, collect, consider data, analyze the data, and interpret the data. GACE 2 also provides learning outcomes for the process at 3 levels, A, B, and C. These are meant to be developmental levels, not age-dependent, but school-wise, the levels are ideally roughly equivalent to elementary, middle, and high school. The Georgia Framework for Statistical Reasoning, ask, collect, analyze, interpret, is the statistical problem-solving process. It is the big umbrella for how all real-life scenarios involving data should be approached. Statistics is about answering investigative questions with data. As we go through the statistical problem-solving process, there are 4 types of statistical questions we will employ: interrogative, investigative, data collection, and analysis questions. Young students at level A are reading books about lizards in their classroom. They become curious about the characteristics of lizards in Georgia. They pose the statistical investigative question, what do lizards in Georgia look like? The teacher and students use photos of the different lizards in Georgia as their data. The teacher asks the students, what do you notice? What do you wonder? From the students noticing and wondering, some variables are defined, such as, is the lizard legless? What is the dominant color of the lizard? Does the lizard look like a snake? Students can then create a data card for each photo, recording the measurements for the defined variables. Picture graphs could then be used to summarize the distribution of the measurements for each variable, where students can easily observe if one category is more frequent than another. As students evolve to levels B and C, investigative questions become more focused. For example, students in a science class have been studying about disturbed habitats, those that have human development, and natural habitats for lizards. The students are interested in exploring the following statistical investigative question. How can a lizard's mass be used to predict whether it came from a natural or a disturbed habitat? Some interrogative questions to check for clarity that we might ask of the post-investigative question are, is it a specific type of lizard or any lizard? Is it for a specific geographic reason? What is meant by mass? The students consider a secondary data set where a research biologist captured randomly a number of individual lizards across 2 habitats on 4 islands in the Bahamas. Some possible questions for interrogating the data to judge if this secondary data set is reasonable for answering the post-investigative question are, what are specific details about the Bahamas geography? How were mass and head depth measured? What units were used? Can this secondary data set reasonably answer our statistical investigative question? How would we approach analyzing the data? Using the open source web-based statistical software CODAP, we constructed dot plot representations of the mass distributions for the natural and disturbed habitats. We would expect a level B to C student to approach the analysis of the data by comparing these 2 distributions with respect to shape, center, variability, unusual features, and separation overlap. To answer our investigative question, we might focus on the separation of the distributions and ask where we could draw a cutoff line to develop a classification rule. Classification is a key data science idea. Since there is an obvious separation in the two distributions at 6.26 grams, students may initially apply the classification rule, classify all lizards with mass less than 6.26 grams as natural. We now ask the analysis question, how often do we misclassify the lizards based on using this classification rule? We find the misclassification rate to be 33%. Since 33% seems too high for our comfort, now we ask the interrogative question, can we improve the misclassification rate with a new classification rule? If the line is moved to 5 and we use the classification rule, classify all lizards with mass less than 5 grams as natural, we find the misclassification rate as 26%, a reduction of 7%. A possible interrogative question at this stage of the process might be, is it possible to reasonably classify a lizard using 2 predictor variables instead of just 1, including head depth? This leads to a new statistical investigative question. Can a lizard's mass and head depth be used to predict whether it came from a natural or a disturbed habitat? All components of the statistical problem-solving process continue with this new question. In summary, the foundational pillar of statistics and data science is the statistical problem-solving process and its 4 components. Questioning continually throughout the statistical problem-solving process is essential. From kindergarten through high school and beyond, students will work with the same problem-solving process, picking up new tools for their toolbox as they develop the conceptual understanding and statistical habits of mind to appreciate the beauty of statistics, but also to be healthy skeptics of statistical information. I am excited knowing you will inspire your students to become sound statistical thinkers. Thank you for joining me today. So that gives you a sense of some of the work that ASA has been doing to try to promote and advocate for more statistics and data science in our school level curriculum. And as we move forward and think about these disruptions that affect the way that we are teaching and the pedagogy that we use and the content that we use, I think we now have to think about another major disruption which has come forward, and that's AI and ChatGPT, for example. How is this going to affect the way that we teach our students? How is this going to affect the way that we train our teachers to work with AI, to be using AI in a positive way as they try to help students become statistically literate? So in summary, I think what we hope will happen not only at the school level, but everywhere, is statistical literacy is for all. And we truly believe that it needs to start at a young age. And Carol was one that believed this. And she worked very hard to promote the work that many were doing at the school level to try to get more statistics and data science into the curriculum. I'd like to read a quote here. You can read this. This is from Steve Levitt of Freakonomics. Basically, what Steve Levitt was saying is what ASA believes, that statistical literacy has to begin at the school level, and that it is important that starting with kindergarten, we help our children to think about variability, to think about data,
and how to work with data, how to collect data, and how data surrounds them and affects them. So here are my final thoughts. This is a picture of my 2 grandchildren. I'm actually in Virginia right now with my 2 grandchildren and my son and his wife, the one that's the forester. We're waiting for a 3rd grandchild any day. And when I look at my grandchildren, I think this is what motivates me, and I think this is what motivated Carol, that these are our future. Our students are our future. And the impact of data on our world is growing faster than we can keep up with it. And that is so true in terms of education as well. We right now are working on the revision of the SET document, the Statistical Education of Teachers, what we're going to call SET 2. And we're trying to write this document when we're watching AI quickly affect how we work with data and how we think about data. And we're trying to figure out what can we predict for 5 years from now, because things are changing so quickly. I truly believe that data sense making and statistical thinking must be as core to K through 12 as reading and numeracy. And the key to this happening are teachers. Teachers are key to meeting the goal of statistical literacy for all, impacting positively the lives of students. Because we want those students to be successful in the workplace, we want them to be successful in their community and also their personal lives. And finally, I firmly believe that the statistics community itself must be actively involved in supporting statistical literacy at the school level. And this final bullet here is where I would like to end by saying that is exactly what Carol believed. My colleague and friend firmly believed that it was important for statisticians to be involved with statistics education. And she devoted so much of her life and her time to that effort. So once again, thank you so much for letting me share with you today and to have a small part in honoring Carol.
Thank you so much for that great presentation, Chris. Very interactive. There was a question related to the COVID activity. The plots, when you showed the 2, the one on the left was the one that was
Yes,
released?
yes, that was the one that was re-released. Yes.
Thank you. So we do have time for questions or comments. So audience, please feel free to put anything in the chat or to raise your hand, and we're happy to take questions. Go ahead, Chris. Sorry, did I interrupt you? Were you going to say something?
No, I was going to pull up the chat so I could see what kind of questions.
There was a discussion about how much data we produce every day.
That was the latest fact that I could find. I suspect it's more. I think it gives you a good sense, though. I think that I found that when I work with students, even with teachers, people have no idea how much data they are generating every day. We just take it for granted.
Yeah, that's definitely true. And I think there's a lot more reliance with social media to use videos, which also require a lot more data.
Oh, that's exactly right. And as I said, one of the things that I think is so important for working with photos, for example, is the ethics that's behind using photos and the information that you're releasing with those photos, and how you maybe can prevent that information from being released. I also want to note with the photos, did you notice in the video, one of the reasons I wanted to show you that video was how we were promoting the use of photos even at the elementary school level, at level A. So, you know, I think what we have to help our students understand is that data is not numbers now and categories that are in simple spreadsheets. Our data is images, it's photos, it's sounds, it's text. And we've really got to give our students experiences working with what we think of as non-traditional data. And we also have to give students experience working with large data sets and the questioning that goes along with working with the data that we pull from the web or wherever we might get these large data sets.
That's a good point. And I'm sure it makes it a lot more exciting too to think about these alternatives instead of just looking at numbers or text.
It's very exciting, and students actually get into that. I mean, this really excites students, and we have the technology now to where we can do so much with that. If you go to the STU website that's at ASA, there are some activities that have already been developed for teachers to use dealing with photos and what you can do with those photos. And students really become engaged with it.
Yeah, that's really cool. Mark, I see your hand up. You can go ahead and ask your question.
Oh, okay. Thank you. Thank you for giving such a wonderful presentation and tying it so closely to Carol. That was amazing. I guess I'll have an easy, what I think is an easy question first. With so much online data and stuff you can pull off from what we've seen in the quantitative literacy visualization posters and stuff, they use these data. What's the difference? How do you value using that and being able to use more complicated analysis versus the value of collecting their own data and learning how hard it is and what it means, you know, maybe tells you what it means for that data?
Well, I think we're promoting both. We think we need both.
Oh no, yeah, I think you do. Okay. I guess I've seen it just lean really far from one way toward the online data because it's so easy to get.
It's so easy to get. That's exactly right. But and one of the reasons we really promote starting at a young age, a good point that you brought up about collecting your own data. It's so easy to collect data at a young age within a classroom. And so students can begin to get a sense of some of the difficulties with collecting data if you start them at a young age, and you can find where they're collecting the data to a space that they can manage, maybe within their classroom, within their school. And then as they advance to middle school, they begin to see the difficulties with how they select data once they go outside their classroom. And so it's what's going to happen once they get to high school. They're going to be wanting to work with the bigger data sets that the easier data sets they can pull from the web. But we definitely promote that they have experiences with both types of collection. One thing we did in GAZE too, we changed it. Instead of just collect data, we changed it to collect, consider data, to sort of separate the idea of actually physically collecting your own data versus considering data that you draw from another source, to make that distinction.
Oh, thank you. My other question is, there's a lot of work like by the Alliance for Decision Education and stuff on students making good decisions and things like that. And is there any effort to like combine decision-making skills, learning the biases, doing that, and then seeing how, oh, what decisions do we need to make? What data could we use to inform those decisions? And then treating it as part of actually making the decisions rather
Well,
than.
what you just asked is exactly what you'll find in the Gaze 2, the updated Gaze 2. Those are recommendations. Those very recommendations are contained in there. And so hopefully there's examples there that give teachers the experience with knowing how to take students through that. And that kind of comes under the general category of questioning. So once you make a decision, you need to step back and question whether you need more data. Have you really answered your investigative question? So all those skills that you're speaking of, those are recommendations we're making in our documents.
That's good to hear. Thank you.
Any other questions or comments?
I noticed that Roxy put in that we're going to miss Carol at the joint statistical meetings. That was always when her birthday usually fell, is in August when we had JSM.
Yeah, August 10th.
Yeah, thank you for the comments in the chat. This is really nice. Well, I would like to thank Mike and Chris again. Thank you so much for being here today to remember and honor Carol. And I'd also really like to thank Sabrina Zhang, one of our WSS representatives at large, who's assisting with technical support in the background. Thank you so much. And thank you everyone to attending. We really appreciate it. And I think this was a really great way to remember and honor Carol. So thank you for being here. This presentation was recorded, and so we'll post on the WSS YouTube channel, and you can share it with any of your colleagues who weren't able to make it today. If you have any questions or suggestions on future topics or presenters, you can reach out to me. I'm going to put my contact information as well as the link for the WSS website and our YouTube channel so that you can get the recording in the chat. Thank you all for attending today's seminar.
Thank you again for letting me join you.
Yeah, thank you both. It was a wonderful presentation.